want you to keep in mind, here's where we are today. We're going to spend today and tomorrow on 2.6, but this is our last section in this chapter. So today and tomorrow on 2.6, 2 days of review, and then a test. Okay? 2 days of review. Okay. So today we are going to talk about an absolute value inequality. Okay? Well, what do you think an absolute value inequality is?
Probably absolute value inequality.
An inequality
Kind of like the equation.
that contains an absolute value expression. Okay, so we have an absolute value with an algebra expression inside of it and an inequality outside of it. Question for you. How many answers did we have in an absolute value equation? 2. Okay. So we're going to have a similar thing happen with inequalities. But when we have 2 inequalities, what do we call those? Mm-hmm. Say it louder for the people in the front. Compound inequalities. Okay. Okay. If we ever refer to the absolute deviation, that basically means this right here. X minus a number with the absolute value. Okay?
We just put x minus n.
Sure. Okay. So, I want you to come down here. We have 2 different compound inequalities. We have and, we have or. Based on the inequality sign, it will determine, do we have an and, do we have an or? Okay. So let's say, down here where it says notes, okay, I'm going to kind of rephrase what it says up there. Let's say we have the absolute value of ax plus b is less than c. So if we have an absolute value inequality that is less than a number, we are going to break this up into 2 different inequalities. Okay? The first one we're going to keep as normal and just say ax plus b is less than c. Okay? When we have the less than sign, the compound inequality is going to be and. Okay. Now, what did we do with our absolute value equation when we split it up into 2? One of the answers was negative. So we're going to do the same thing here, where c is going to become negative, but that also means we need to flip our sign. Okay? So we need to flip. So flip this sign, flip this sign. Is it okay if I just say flip, flip? Okay. Okay. Now, if we have the absolute value of ax plus b is greater than c. Okay. We are going to do the same thing where we are going to keep our inequality the same. Ax plus b is greater than c. But this time, our greater than sign is going to mean we're doing an or compound inequality. And again, we're going to take ax plus b. We're going to flip the sign, flip the sign. Now, sometimes I can get a little cheesy. We basically need to know which one is and which one is or. So I like to remember that this is greater than, or greater. You hear it? Greater than, less than. Use it or don't use it, I don't really care. What's that?
How do you know which ones make negative?
So you're going to keep your inequality the same. Then when you rewrite it for the second time, when you flip the sign, you also change this sign. Okay, so it's flip the sign, flip this sign.
So you always change it to be negative, the one that's opposite.
Mm-hmm.
So then, wait, so then.
Okay. Okay, so I'm going to give you a piece of paper that I need you to fold like a little book. Where example 1 is like the front cover. So fold it so example 1 is the front cover. Can I squeeze through here? All right, so we're going to look at example 1. Okay, so just like with our equation, it's going to be important that we get the absolute value by itself. So if there's anything outside of the absolute value that needs to be moved to the other side, we would need to do that first. Do we have to do that in example 1? No, we just have the absolute value of x is less than or equal to 12. Okay? Now, what we get to do is we get to break this up into 2 different inequalities. Okay? So we're going to ditch the absolute value sign. And inequality 1 is the exact same. But inequality 2, we take the sign and we flip it. We take the constant and we negate it with the yes. Okay. Then we need to decide if it's and or. So since we have a less than or equal to, less than, we have and. All right, now solve the inequality. Right now we have x is less than or equal to 12 and x is greater than or equal to negative 12. I don't have anything to solve. If I had an expression inside of my absolute value, we would have something to solve, and we'll get there, okay? I am pretty flexible. If you leave it like this, I'm fine. But I also want you to understand that if it's an and statement, we can write it as a sandwich, but you do not have to if it makes you nervous. Okay. I am totally fine with this answer right here. Okay. Now, if you're a little nervous, you could always say, all right, I can pick a couple numbers in my solution set and go back to the original. Like if I choose 1, is the absolute value of 1 less than or equal to 12? Yeah. I can choose negative 10. If I plug it in, does it work? Yeah.
Do you want the negative 12 on the left side, or does it really matter?
So I like when you write this, I prefer it to be a number line order. So yeah, I would want the smaller number over here. Okay. I'm not going to count it wrong. It's just going to look nicer. Okay. Was that your question?
No, I have a different question to that.
But now you don't?
Yeah.
Okay. All right. So if we were to graph this, we would have a closed circle at negative 12, a closed circle at positive 12, and all the values in between. Joey, here's your Baymax eyes. Did you have a question?
Shouldn't that be kind of considered or?
No,
Because the arrows are pointing the opposite directions.
they are not. Well, correct, but we can write it like when I write it with x on the right side, now our inequalities look like that. Okay, anytime our absolute value is less than or equal to a number or less than a number, we're going to have and. Okay, all right, let's look at example 2. Looks like that, right? You totally can't tell that I added in a -1, right? Ah. We have the absolute value of x minus 1 is greater than 5. Do you agree? Okay. Is the absolute value by itself? No. What do we need to do to both sides in order to get the absolute value by itself? We need to add 1 to both sides. So if we add 1 to both sides, we have the absolute value of x is greater than 6. Okay. Ooh, I heard somebody getting excited that we have great or. We have an or statement, right? Okay. So when we split this up into two inequalities, we ditch the absolute value sign and we keep it as is. We ditch the absolute value sign, we change the sign, change the sign. So what we're dealing with, x is greater than 6 or x is less than -6. Since I didn't have anything more than x inside the absolute value, we don't have any more algebra to do. It will be important, though, that you write or. If you don't write or and you just give me these two inequalities, I can't give you full credit, and I'm sorry. Okay. Okay, so we have a +6 that we are greater than. And we have a negative 6 that we are less than. All right, let's go to example 3. Let's get a little bit more exciting here, huh? In example number 3, do we have to do anything to get the absolute value by itself? The absolute value of x plus 5 is already by itself, so we don't have to do any extra work before we split it up into two inequalities. So we are going to ditch the absolute value sign and keep our inequality the same. We are then going to ditch the inequality sign. Excuse me, the absolute value sign. I said that wrong. We're going to ditch the absolute value sign, and we're going to flip and flip. Thumbs up for and, thumbs down for or. Great or, less than. Okay, so if we have x plus 5 is less than 9 and x plus 5 is greater than negative 9, we do have two different inequalities we need to do more algebra with. Okay, in both cases, what do we need to do to both sides? We need to subtract 5 so that we have x is less than 4 and x is greater than negative 14. Okay. Again, I am totally cool with you leaving your answer like this. But when you have an and statement, it is also okay to make it a sandwich. Okay, so negative 14 and 4. We have an open circle at both, right? And if we are greater than negative 14 and less than 4, we've got this going on, right? Okay. Do you have a question before we go to example 4? All right. Example 4 looks like this. Kind of a weird one, isn't it? What'd you say? Not a weird. Okay. Joey's excited about this one. It's not scary. All right, Joey, what do we got to do?
We'll first start with
Okay, so we do not want this 2 right here. We need to undo it so that the absolute value is by itself, so we're going to divide by 2 to both sides. So the absolute value of negative 6x is greater than or equal to 30. It is okay that there is a negative inside the absolute value. Okay. What we are going to do is we are going to ditch the absolute value and keep the inequality the same. Ditch the inequality and flip the sign. Make sure you're flipping the sign of the number, not the expression. Okay.
So basically,
As a team. Okay.
we can put four things that you think.
Okay.
And if you want to like star the one that you think, how do I fix star the one that you think? It's easiest fix. Like we
Okay.
want to get like an easy win to start with, you know what I'm saying? So
Mhm.
there's a things we want. This one is not a huge deal, and we think it wouldn't take a whole lot to
Okay.
get. Does that make sense?
Yep. Okay. Okie dokie. And or? Great tour then. Okay. So we have negative 6x is greater than or equal to 30, or negative 6x is less than or equal to negative 30. Okay? Our rules still apply when solving these inequalities. We're going to divide both sides by negative 6. And what happens to our sign? It flips. So what we have going here is x is less than or equal to negative 5, or x is greater than or equal to 5. What's up, Joey?
I have another strategy, but it may be a little bit complicated. Kind of do like opposites.
Well, it's not always going to be opposites, though.
Maybe.
In the case where we don't have anything like added or subtracted inside, we're going to see that. But, you know, in this example, we had x plus 5, so we didn't end up with opposites. Okay? Okay, going back to your student journal, I would like you to try number 1 and number 3. Ready, set, go. It was just the next page, like 56. Number 1 and number 3. Am I cool if you work with your elbow partner? Yes. You know what? Taking attendance is probably a good idea. do about one more minute? You guys are really quiet. Does this mean you understand it and don't need your elbow partner? Or all the unified kids are back.
Lucas. 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 How'd it go? Was it good? Hi, Miss Nixon. Miss Nixon. She said hi.
Okay, in number 1, do you have y plus 2 is less than 8 and y plus 2 is greater than negative 8?
Yeah.
So then you have y is less than 6 and y is greater than negative 10?
Yeah.
Yeah? Okay. So your graph would look like this?
Yeah.
Yeah? Okay. Can I answer a question for you?
Sure.
Do you have one? No. Oh, that's what I meant. Okay. Number 3. Before we can split into 2, we better add the 10. And by add, I mean subtract. And then divide the 3. So the absolute value is less than or equal to 9. Right? So we have 2a plus 5 is less than or equal to 9. And 2a plus 5 is greater than or equal to negative 9. Do you agree? Okay. So when we do the algebra here, we have 2a is less than or equal to 4, which means a is less than or equal to 2. And, let's see, a is greater than or equal to negative 7?
Yeah.
Like that?
Yep. Yeah.
Okay. Aubrey, are you okay with this?
Yeah, I did.
Oh, shoot. I wondered why your numbers were so big. Okay. Okay.
I saw a 3, but I didn't know how to subtract it. 7.
Okay. All right. So, take a deep breath. Let's see. Negative 6, negative 4, negative 2, 0, 2. I don't know if I had enough room or not, but there it is. Okay. So, you're going to have a book assignment.